Hey children, welcome to Top Scholars. Again, we are going to do a one-shot series on determinants. So in this session, we are going to cover the chapter Determinants. So before starting the chapter exactly, let us try to understand what exactly is a determinant. So, a matrix. To get a determinant, we need a matrix first. A matrix must be square. So do you remember what a square matrix is? Correct. Square matrix is that matrix where the order is m cross m, right? That is, the number of rows is equal to the number of columns. Then we call the matrix a square matrix. So it is a compulsion that if you want to find out the determinant of any matrix, that matrix has to be a square matrix. That is, the number of rows equals to the number of columns. Just now I mentioned that to have a determinant. Now let us see an example. Now have a look at this. We have a matrix A, and in this matrix A, how many rows are there? Can I say there are 2 rows? So this is your first row. I can call this as R1, and then this is your second row, that is R2. How many columns are there? Can I say there are 3 columns? So basically we have 2 rows and 3 columns. So tell me one thing, the order of this matrix is 2 rows, 3 columns. Is it the number of rows equal to the number of columns? Can I say that? No, definitely. That means we cannot find out the determinant of this particular matrix. 2 rows, 3 columns. So not have a determinant. That means we cannot find out the determinant. So what is compulsion here? The compulsion is that the number of rows and the number of columns must be equal. Okay, let's continue further. Now, here is an example. Now, how many rows are there? Clearly, there are 2 rows. Correct. How many columns are there? There are 2 columns. Can we find out the determinant? Yes, we can find out the determinant. So see here, 2 rows, 2 columns. That is equal. Number of rows and number of columns are equal. So the dimensions of the resulting matrix are 2 by 2. We read it as 2 by 2 matrix. We have learned that in matrices as well. And then we can find out the determinant. But how to find out the determinant, that also we are going to see. Okay. Let's continue. So for a matrix of size n cross n, now what is the meaning of n cross n? That is, the number of rows is equal to the number of columns. So if we have a matrix whose number of rows and the number of columns are equal, the determinant is called the nth order determinant. So this determinant is basically called as the nth order determinant. Okay. So here is an example. So here we have a matrix, matrix A. The elements in the rows are 3, 1 and 4, 2, right? So clearly this is a 2 by 2 matrix, and we will say because it is a 2 by 2 matrix, it has a second order determinant. If a matrix is 3 by 3 matrix, it has a third order determinant. If a matrix is 4 by 4 matrix, we have a fourth order determinant. In this entire 12th standard, we are going to deal with only second order determinant and third order determinant. That means maximum you will have 3 rows and 3 columns. Please make a note of this. Let's continue. Okay, so order of the matrix is 2 by 2. Now for a matrix of size or order also you can say n cross n, the determinant is called an nth determinant. We just now saw that. But how do we find that out? We are also going to see. Now suppose there is a matrix A and it has only one element. So can I say it is 1 cross 1, right? That is 1 row and 1 column. So the order of this matrix is 1 cross 1 or 1 by 1, correct? And the determinant of this is nothing but the element itself. For example, A is 2 here, then the determinant of A will be given by 2. Simple as that. So the order of the determinant is nothing but 1. Why 1? Order is 1 because the matrix is 1 cross 1. I hope this part is clear to you. Alright, let's continue. Now here we have one more matrix. What is the order here? The order of this matrix is 2 by 2. That is, there are 2 rows and 2 columns, isn't it? So here we have 2 rows and 2 columns. Now let us take an example. Basically what we have done is, we have taken A as 1, Then we have taken B as 3, C as 5 and D as 1. We have just taken an example here where the matrix A has elements 1, 3, 5 and 1, right? So what is the order of this determinant? If I just talk about the order is 2. Why? Because there are 2 rows and 2 columns. Simple as that. This part is clear. I hope the order part is clear to you. But we are also going to see how to find out the determinant now. Okay, let's continue. So determinant of a 1 by 1 matrix. Now this is a symbol, right? So this symbol is nothing but the representation of determinant. Now understand that this is the symbol of determinant. It is not the symbol of modulus. We have studied about modulus in our lower grades as well. Mod of something, right? So when we say mod of 2, or we can say mod of minus 2, the answer to both of them is 2. That is the absolute value. Examples of mod like your weight. If I ask you what is your weight cannot be negative, right? If I ask you height cannot be negative. So that is all modulus. But here we are talking about determinant, and determinant has no relation with modulus. So determinant of a matrix can be positive also. Determinant of a matrix can be negative also. Determinant of a matrix can be 0 also. So please don't mix up your determinant with your modulus. Both of them are two different things. I hope this part is clear to you. Okay. Now let us take an example. Here we have a matrix A which has only one element, that is 1 cross 1. It is 5. So the determinant is the same number there. So the determinant of A is 5. If it is minus 5, the determinant is minus 5. Don't make it positive. As I said, this is not modulus. Okay. Okay. Let's continue. Now here we have a matrix C which is minus 8. The element is minus 8. So what will be the determinant? The determinant will remain the same. That is minus 8. The order is 1. Okay. Now let us talk about the determinant of 2 by 2 matrix. Now how do we find out the determinant of a 2 by 2 matrix? We need a matrix, of course. There should be 2 rows and 2 columns. So here we have a matrix that is A, and the 4 elements are A, B, C and D. Correct? Now understand, to find out the determinant of matrix A, first of all we'll write down these 2 vertical lines here and the elements inside it, that is A, B, C and D. Now how do we find out the determinant? Determinant of A is given by, firstly you'll multiply A and D. So what are we going to do? We're going to multiply A and D, and then we're going to subtract the product of the other 2 elements here, that is B and C. I hope this part is clear. That is A multiplied by D. So first of all, you multiply the elements of the leading diagonal. So A and D, leading diagonal first, then B and C, and then subtract. Don't do it in the reverse manner, otherwise the answer will go wrong. Okay. So here we need to find out the determinant of A, and this is how we can find out the determinant of a 2 by 2 matrix. Please make a note of this. Okay, let's continue. Now let us take an example. So here it is. We have a matrix and the elements of the matrix are 1, 2, 3 and 4. So see, your A is like 1, your B is 2, your C is 3 and your D is 4. So what are we going to do? Firstly, we will multiply the leading diagonal elements, right? So let us see how are we going to do that. So the determinant of 1, 2, 3, 4 is given by, firstly, you multiply 1 with 4 and then 2 with 3 and subtract both of them. So 4 multiplied by 1 minus 3 multiplied by 2. 4 1s are 4, 3 2s are 6. So can I say the answer is going to be 4 minus 6, which is negative 2. So yes, please make a note of this, that the determinant can be positive, it can be negative also, which I told you in the beginning as well, right? So let us continue further now. Okay, now comes determinant of a 3 by 3 matrix. So how do we find out the determinant of a 3 by 3 matrix? Let us have a look at it. For that, we need how many rows? We need 3 rows. We need how many columns? We need 3 columns. So let us see. So here it is. We need to find out the determinant of this particular matrix. So this matrix has 9 elements, 3 rows, 3 columns, right? A, B, C, D, E, F, G, H, I. Okay. So how do we find out the determinant? How do we find out the determinant for this? Now please understand very carefully. Firstly, you select the row. Step 1 is select the row. You can select any row, but preferably take row 1. Let us stick to one strategy here. Row 1 we will pick up. Now, what you do is, you give alternate plus and minus sign to these. Write down plus here, write down minus here, write down plus here. So this is plus, minus, plus. That is second step. Third step is select the first element. That is A. So we will select A. Now after selecting A belongs to first row, first column. Ignore the first row and first column. That means ignore it. What is remaining? These 4 terms are remaining. Now this is like your 2 by 2 determinant. Multiply that element A with the 2 by 2 determinant first. So how are we going to write it down? We are going to write down A, and then we are going to write down E, F, H, I in the form of determinant of order 2. I hope this part is clear. Okay. Now what you do is, after that, you select the second element of the first row. But I told you, it is alternate plus and minus. See, this is plus, no? This is plus. Now you will write down minus. So there, you are going to take minus B, ignore the row and the column in which B belong to. Write down minus B and take the remaining elements here. I hope this part is clear. Now what is next? Now next is the last term, that is C. Take C. C belongs to first row, third column. Remove first row, third column. What is remaining? D, E, G, H. Just take it there. Write down plus, then C, and then the remaining elements inside the determinant of order 2. So you can see there is alternate plus minus. This part is plus, here we have minus, and then again we have plus. So please remember that the middle one is always minus. If you write down plus there, our answer will go wrong, isn't it? Okay, let's continue further. I hope this part is clear. So if you solve this further, what are you going to get? You will write down A as it is. See, understand. You will write down this A here. And then now you know how to solve a 2 by 2 determinant. E multiplied by I minus F multiplied by H. Then here you have minus B. Then D multiplied by I, F multiplied by G. And then here you have C, D multiplied by H and E multiplied by G, and minus in between. So it can be lengthy, but it is very simple. It is basic math. You just have to multiply numbers there. Make sure that you don't make mistake in the sign, and then solve it further. Correct? Let's continue. Okay, let us take an example now. So here we are supposed to find out the determinant of this particular 3 by 3 matrix. The elements are there 2, 3, 1, 1, 0, 4, 5, 2, 1. How are we going to do that? First we will pick up 2. Then ignore the first row, first column. Correct? Then write down 2 and then the determinant of this. Then remember, if you remember, this was plus, minus, plus. That is the first thing you do so that you don't forget. Then write down minus 3. Minus 3. Ignore the first row, second column. 1, 4, 5, 1 is left. Put it inside the determinant. Then you have 1. That will be plus 1 only. The third one. Write down plus 1 and then write down 1, 0, 5, 2. Now you know how to solve this. This 2 remains as it is. This minus 3 remains as it is. 1 remains as it is. Inside you have to cross multiply and subtract them. So let us see how does this look further. So here we'll have 0 multiplied by 1 and then 4 multiplied by 2. 0 multiplied by 1 is 0. 4 2s are 8. In the middle minus sign. Then you'll have minus 3. 1 multiplied by 1 is 1. 4 multiplied by 5 is 20. So minus 3, 1 minus 20. Here also 1 multiplied by 2 is 2. 0 multiplied by 5 is 0. So 2 minus 0 is 2 further. So here 2 multiplied by minus 8 is going to give me minus 16. Now this is 1 minus 20 is minus 19. Minus 3 multiplied by minus 19. Further it is going to be positive and that is plus 2. So this becomes plus in the middle. Minus 16 plus 57 plus 2. And the final answer that you get is 43. So what is the determinant of this? It is 43, and 43 is your final answer. I hope this part is clear to you. I hope you have understood how to solve a matrix and find out its determinant where the matrix is of order 3 by 3. Correct? Let's continue. Now let us see some problems on determinant. Find the value of x if the determinant of sin x, cos x, sin x is 1 by 2. Now see, firstly you understand the order of the determinant. What is the order here? The order of the determinant is 2, correct? Because there are 2 rows and 2 columns, and we know how to solve the determinant. We just have to multiply sin x with sin x. We have to multiply cos x with cos x. We have to put minus sign in the middle and then solve it further. And make sure that whenever you have questions based on trigonometry, you know all the formula of trigonometry as well, because that is going to be used here. Alright? Okay, let's continue. So here we have determinant of sin x, cos x, sin x is equal to 1 by 2. How are we going to start with? We are going to start with multiplying sin x with sin x. So sin x multiplied by sin x is how much? Sin square x. Cos x multiplied by cos x is how much? Cos square x. So this is sin square x minus cos square x is 1 by 2. Correct? But if you remember, can I write this as cos square x minus sin square x? Because cos square x minus sin square x, if you recall, gives me some formula, right? So what I'm doing is sin square x minus cos square x, I'm writing it as cos square x minus sin square x, and minus, it does not make a change, right? Because minus into cos square is minus cos square, and minus into minus sin square is plus sin square. Same thing. Now recall what is cos square x minus sin square x. Cos square x minus sin square x is sin 2x, right? The formula for sin 2x is cos square x minus sin square x. So here, instead of cos square x minus sin square x, can I write down sin 2x? Yes. But if you recall, there is a minus sign outside here. So minus of sin 2x is equal to 1 by 2. So can I transpose this minus sign to the other side? I can do that. So I'll get sin 2x is equal to minus 1 by 2, isn't it? See here. So sin of 2x is minus 1 by 2. So definitely, can we say 2x will be equal to sin inverse of minus 1 by 2? Now sin inverse of minus 1 by 2. So we know that sin inverse of which value gives me minus 1 by 2? Definitely 2 pi by 3 and 4 pi by 3. We are only going to take the principal values, right? So that's it. We have two values of x here. That is 2 pi by 3 or 4 pi by 3. I hope this part is clear to you. Let's continue. Now here is the question. The question says, the determinant of this is 0. Find the value of alpha. Now how do we do that? The procedure remains the same. You need to know how do we find out the determinant of a 3 by 3 matrix. So firstly, we are going to start with alpha. Correct? Let me write down the given information here, that is the determinant is equal to 0. So we'll start with this, that is alpha. Then we will take the determinant of this. Then we'll take minus 3. Then the determinant of the remaining as per ignoring the rows and columns. And let us see how does this look like now. So here it is. We have alpha and then 2, 4, 1, 1. Then minus 3. Ignore the first row, second column, 1, 1, 1, 1, isn't it? And then plus 4. Ignore the first row, third column, 1, 2, 1, 4. Correct? Now you need to solve this. 2 ones are 2, 4 ones are 4, and subtract in the middle. So this is 2 minus 4. This is 1 minus 1. This is 4 minus 2. Correct? Outside we have alpha. Outside we have minus 3. Outside we have 4. Just solve this further. 2 minus 4 is minus 2. So you get minus 2 alpha. This will become 0. That will become 8. So minus 2 alpha plus 8 is equal to 0. 8 will be on the other side. Minus 2 alpha is equal to minus 8. Alpha is equal to 8 by 2. The value of alpha that you are going to get is 4. Simple. So in this way you can find out the value of the unknown here. I hope this part is clear to you. Let's continue further. Okay, the question says, we have the determinant of x sin theta cos theta minus sin theta x1 cos theta 1x, and we are supposed to prove, basically the question says prove that this determinant is independent of theta. It is independent of theta means what? It's very simple. That is, this determinant is not dependent on theta. Obviously, dependent is opposite of independent, but again, what does it mean? It means that the determinant that you get at the end should not include theta. If there is no theta at the end, then we can say it is independent, isn't it? So, we'll solve it and we will see at the end whether we are getting theta or not. If we are getting theta, that means it is dependent on theta. If we are not getting theta, it is independent of theta. Simple as that. Let's solve this. So what do we have? We have the determinant. We know the procedure now. I am not repeating that. Directly let us expand it. So here it is. We have x, then the determinant of this part. Then we have minus here, right? Minus sine theta, the determinant of minus sine cos 1 and x. Then we have cos theta, which is plus. And then we have minus sine x cos and 1. I hope this is clear. So this you can multiply further and solve. Let us see what do we get. We get x multiplied by minus x multiplied by x is x square, minus x square of course. And then 1 ones are 1. This is minus sine theta. This is x into minus sine theta, that is minus x sine theta. This is cos theta into 1 cos theta. Minus sine theta into 1 is minus sine theta. This is minus x cos theta. Correct? But because we have minus in the middle, that becomes minus minus plus x cos theta. I hope you got why there is plus here. Simple. Let us solve this further. So further, when you expand the brackets, open the brackets, you can say, you get minus x cube minus x plus x sine square theta, then plus sine theta cos theta, minus sine theta cos theta, and then x cos square theta. Can I cancel this? Yes, I can do that because both of them are same. Sine theta cos theta positive, sine theta cos theta negative, positive negative gets cancelled. Now what is left? We are left with x sine square theta plus x cos square theta. Can I take x common from there? Yes, I can do that. And then what is sine square theta plus cos square theta? One of our favorite formulas, isn't it? That is 1. So what happens is that becomes x. X into 1 is x only, no? Now this is minus x. This is plus x. Again we can cancel this. What is left? Only minus x cube is left. So the determinant of this is equal to how much? Determinant of this is equal to minus x cube. Now tell me one thing. Does the determinant include theta? No, there is no theta there. Directly we have the x value. So definitely it is independent of theta. That is what we were supposed to prove, and we have proved that. I hope this part is clear. Simple. So finally we can say that independent of theta because theta is not available in the final value. That is, theta is not there in minus x cube. I hope this is clear to you. Let's continue. Now some important properties of determinants we are going to see. All these properties you need to know because once you know the properties, you will get to know which property to apply in the question. There are almost 7 properties here. We will see these properties one by one. So the first property is the property of identical or proportional rows or columns. Now, if any 2 rows or columns of a matrix, are identical, identical means same, if they are same, or proportional. Proportional means if they are scalar multiples of each other. I'll tell you the examples as well, don't worry. The determinant is 0. So when is the determinant 0? The determinant is 0 when any 2 rows or any 2 columns of a matrix are identical. Either they are same or they are in proportion. So let me give you an example of identical first. Can I say row 1 and row 3, both of them are same, that is they are identical? Then if you find out the determinant, you are going to get the determinant of this as 0. Same thing applies for column. Have a look at this. The first 2 columns are the same. Again, we can say that the determinant of this is 0. So the determinant is straight away 0 when the 2 rows are identical or proportional also. We are going to see the example of proportional as well. Let us have a look at an example here. So show that the following matrix, directly we are having an example, show that the following matrix has a determinant of 0. Now here we have a matrix. We have 2, 4, 6. We have 1, 2, 3. We have 1, 7, 12. Now looking at this, do you think the rows or columns are identical? Have a look at that. It doesn't look like. But if you look at the first row, that is 2, 4, 6. Can I say 2 is common in all of them? Can I write down 2 as 1 multiplied by 2, 4 as 2 multiplied by 2, and 6 as 2 multiplied by 3? Yes, I can do that. So the first row, see how I am writing. 1 2s are, 2 2s are, 3 2s are. Now can I say 2 is common in the first row? Now whenever you have an element common in any row or any column, you can take it outside. So I can take this 2 outside the determinant. If I take this 2 outside the determinant, what will be left inside the determinant? See. So 2 is outside. This 2, which I have circled, is outside. So this 1, 2 and 3 becomes your first row. 1, 2 and 3 is already your second row. And then 1, 7, 12 is your third row. Now can I say these two rows are identical? Yes, they are. So directly 2 multiplied by determinant of 0. 2 multiplied by the determinant of this is 0. 2 multiplied by 0 is 0. You get the final answer as 0. So make sure that either they are identical, or you can see that R1 is a multiple of R2. That is 2 times R2, isn't it? The row 1 is 2 times row 2. That is called as proportional. So it can be proportional also, and it can be directly identical also. That completely depends upon the question, but you have to be smart enough to identify that. I hope this is clear. Okay, let's continue. Now property 2, it talks about interchanging rows or columns. Interesting. If two rows or two columns of a matrix are interchanged, the sign of the determinant changes. When does that change? It changes when two rows or two columns are interchanged with each other. So let us have a look at an example here. Now here we have a determinant, and if you see, we have the determinant A. The first row is 2, 3, 5, second row is 1, 4, 7, third row is 3, 6, 9. Let me find out the determinant of A first. So we'll write down 2 here, multiply accordingly. You know this procedure. That is 4 multiplied by 9 multiplied minus 6 multiplied by 7. Then we have minus 3, the other numbers in the other bracket, and then 5, and finally you have the numbers in those brackets. Solve it further. Let us see what value we get. 2 multiplied by 9 4s are 36, 6 7s are 42, 9 1s are 9, 3 7s are 21, 6 1s are 6, 3 4s are 12. We have put it in the bracket. Solve it further, subtract. This becomes minus 6, this becomes minus 12, this becomes minus 6, this will become minus 12, that will become plus 36, and then minus 30. The final answer that you get is minus 6. Okay. So we solved this and we got the determinant. How much? We got the determinant as minus 6. Now what we will do is, we'll interchange one of the rows or columns. Let us do that. Now this is the first row, this is the second row, R1, R2. Let us change that. So let us change 1, 4, 7. See, R2 becomes R1 now, and R1 becomes R2 now. I hope this is clearly visible to you. Now let us take the determinant of this and let us see what happens. I hope you remember the previous answer. The previous answer was minus 6. So now we should get the opposite of this. So we should get 6, right? Let us see whether we get that. Start by solving the determinant. So 1, 3 9s are, minus 5 6s are, then minus 4, and so on. So 3 9s are 27, 27 minus, this will be minus 30. This is 18, this is 15, this is 12, this is 9. Let's solve further. 27 minus 30 is minus 3. Then this becomes 3, this becomes 3, this becomes minus 3, 1 into minus 3 is minus 3. Basic solving, I don't think I need to explain this. And finally, let us see what is the answer that we get. 21 minus 12 minus 3. So can I say that is 9 minus 3, which is 6? So the determinant of B is 6. Now, can I show you the previous slide? Determinant of A was minus 6, right? So determinant of A is minus 6 and the determinant of B is how much? Determinant of B is 6. So can I say both of them are negative of each other And why did we get negative of each other? We got negative of each other because we have interchanged the two rows. Now, even if you interchange the two columns, then also you are going to get the same result. Clear? Okay, let's continue. Now, let us talk about the third property. If a row or a column of a matrix is multiplied by a scalar k, then the determinant of the matrix is multiplied by k. Very simple and straightforward. If a row or a column of a matrix is multiplied by a scalar k, obviously we are talking about a non-zero scalar here, then the determinant of the matrix is multiplied by k. How? Let us see. So here is an example. So here is a determinant of A, that is, here is a matrix A. We have written it in the form of determinant, that is 2, 3, 1, 4, 5, 6, 7, 8, 9. Okay. Let me find out the determinant of A first. So this is 2 multiplied by 9 5s are 45. Directly we have done it. This is 48. Then minus 3 in the middle. 4 9s are 36. 6 7s are 42. And then 1 at the end. 4 8s are 32. 7 5s are 35. Correct. Let's continue further. So here you will have 2 multiplied by minus 3. Then minus 3 multiplied by minus 6. And then 1 multiplied by minus 3. Solve this further. You will get minus 6. Minus minus becomes plus, plus 18 and then minus 3. So ultimately this becomes 9, right? Okay. So the determinant of A is 9. Now what we will do is, we are going to multiply a scalar. So remember this first. And now what we are going to do is, we are going to multiply a scalar to any of the rows. So I am multiplying row 1 by 3. But you need to know what is row 1, right? So here I am going to multiply row 1 by 3. So what will happen? My row 1 will change to 6, 9 and 3, right? After multiplying by 3. So let us have a look at that. See, 6, 9, 3. The other two rows are the same. Now let me find out the determinant here. Same procedure, we are going to repeat it again and again. So this is 6 multiplied by 45 minus 48, then minus 9 multiplied by 36 minus 42, and then 3 multiplied by 32 minus 35. Solve this further. You get 6 multiplied by minus 3, minus 9 multiplied by minus 6, 3 multiplied by minus 3. Solve it further. You get minus 18 plus 54 minus 9. That gives you 27, isn't it? Now determinant of B is 27. What was determinant of A? From the last slide, the determinant of A was 9, determinant of B is 27. Can I say the determinant of B is 3 times determinant of A? I can write down determinant of B is 3 times determinant of A. What is this 3? But this 3 is nothing but the scalar, right? So this is the same scalar which we multiplied the row 1 with. And what is the result that we got? We got the result that the determinant became 3 times the previous determinant. If you multiply row 1 by 2, you would have got the answer as 18. If you multiply row 1 by 5, you would have got the answer as 45. Even if you multiply any column, in that case also, you will get the multiple. I hope this part is clear. Okay. So comparing determinant A and B, we get, okay, the same thing that we have written here. Let's continue. That is 27. Same thing again, nothing new in this, determinant of A, determinant of B, that is 3 times. So this confirms that multiplying a row, when they say a row, it is not necessary first row, it can be second row also, it can be third row also. When they say column, you can multiply it with any column and you can try it on your own. One example you can do on your own and you can check. Okay, so let's continue. Now let us talk about a triangular matrix. Now do you remember what a triangular matrix is? We have studied about a triangular matrix in our previous matrix session as well, right? So a triangular matrix is a square matrix. Firstly, it is a square matrix. What is the meaning of square matrix? Square matrix means the number of rows is equal to the number of columns. So it has to be a square matrix compulsory, where all elements above or below the main diagonal are 0. All elements above or below the main diagonal are 0. That is called as a triangular matrix. So main diagonal is leading diagonal, okay? So basically there are two types, lower triangular matrix and upper triangular matrix. Let us try to understand both of them. Okay. So here we have the definition and the examples. Lower triangular matrix, a square matrix with all elements above the main diagonal are 0. A square matrix with all elements above the main diagonal are 0 is a lower triangular matrix, and a square matrix with all elements below the main diagonal are 0 is called upper triangular matrix. So have a look at this. All the elements above the main diagonal. So this is your main diagonal, and the elements above the main diagonal are 0 is called as lower triangular matrix. And all the elements below are 0 here is called as the upper triangular matrix. I hope this part is clear. Let's continue. Okay, let us talk about the property now. The property of triangular matrices. So calculate the determinant of the following upper triangular matrix. Now whenever they tell you to find out the determinant of a triangular matrix, all you need to do is just multiply the diagonal elements. I'm writing it here. Multiply diagonal elements. Let us see how. Here is the matrix. Obviously, this is an upper triangular matrix because all the lower elements are 0. So what you need to do is just multiply these. That's it. That is your final answer. Simple. See here, using the property, we have 2 multiplied by 5 multiplied by 7, which is 70. Now why we are getting like this? Because if you want, you can give it a try. Even if you expand it, you are anyways going to get these 3 terms only, that is 2, 5 and 7. And the final answer that you will get is 70. So the determinant of this is 70. I hope this part is clear. Adding rows or columns. Now understand. What happens when we add rows or columns? Adding a multiple of one row, or directly adding a row to another does not change the determinant. Adding a multiple of one row to another does not change the determinant. For example, we have a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, let us find out the determinant first. So, this is 1, 5 9s are 45, 6 8s are 48. This is minus 2, 4 multiplied by 9, 6 multiplied by 7. Then we have 3, 4 multiplied by 8, 5 multiplied by 7. Further, if you solve this, you get minus 3, minus 6, minus 9. And finally, you get minus 3 plus 12 minus 9, which is equal to 0. So the determinant of this is 0. I hope this part is clear. Now, since the determinant of this is 0, now what we are going to do is, we are going to add a multiple of one row to another. Let us see how to do that. Now, understand this statement first. We are changing row 2. We are changing row 2. How are we changing? That is, in row 2, we are adding. We are changing row 2. How? In row 2, we are adding 2 times row 1. That is, we are adding double of row 1. So let us try to understand this first. Now this is your matrix. We are changing row 2. So we are not changing row 1, we are not changing row 3. So row 1 remains as it is. Row 3 remains as it is. In row 2, we are adding 2 times row 1. So what is 2 times 1? 2 times 1 is 2. 4 plus 2 is 6. What is 2 times 2? 2 times 2 is 4. 5 plus 4 is 9. What is 2 times 3? 2 times 3 is 6. 6 plus 6 is 12. I hope this part is clear. This is how we are changing it. Okay, let us see now. So here it is. We are adding 2 times 1. We are adding 2 times 2. We are adding 2 times 3. I hope this is clear. And then I already gave you the matrix. Now let us find out the determinant of that. So you solve it. Put the values. You can have a look. Check the calculation. And see the final answer. Did the final answer change? No. That means we can say that the determinant is 0. It is not compulsory to only have this operation. You can also, here, even if I change in row or column, even if I add, say if I say change C3, change column 3, how we are changing it? Adding a multiple of one row or adding a directly row or column, change it to C3 plus C2. We're changing C3 to C3 plus C2. That means what? Since we're changing C3, C1 and C2 will remain the same. Now C3 will change to C3 plus C2. Now add 3 plus 2. 5 plus 6. 9 plus 8. Even if you find out the determinant of this, you are going to get the same answer, that is 0. I hope this part is clear. So make sure that you can make changes in the row or in the column and the value of the determinant does not change. Interesting, isn't it? Let's continue. So this confirms that adding a multiple of one row to another does not change the determinant. You can add and write down column also there. Now let us talk about a new topic, that is area of a triangle using determinant. We are going to see how do we find out the area of a triangle with the help of a determinant. So the area of a triangle with the vertices at coordinates a x1 y1, b x2 y2 and c x3 y3 can be computed using the determinant formula. What does this mean? This means that we can find out the area of the triangle when the coordinates, that is x1 y1, x2 y2, x3 y3 is given to us. And how do we do that? This is the formula. So area is given by half of, understand the formula first. This is actually the modulus, okay? Mod of the determinant of x1 y1 1, x2 y2 1, x3 y3 1. Now you might wonder, we have the determinant also and then why they have put a mod? Because we are talking about the area, right? And area of a triangle. Can that be negative? No. Can determinant be negative? It can be negative. So if you get the value of the determinant as negative, you're going to ignore that minus sign. That means if you get the value of the area of a triangle as minus 40, is that realistically possible? No. So we'll write down the area is 40 square units. I hope this part is clear. But then the question arises, how are we going to use this formula? To use this formula, we need to know all the three coordinates of the triangle, that is x1 y1, x2 y2 and x3 y3. So x1 y1, x2 y2, x3 y3, we'll put it like this in the first two columns and then 1 1 1 in the last column. Okay. So since area is positive, we always take the absolute value of the determinant, correct? If area is given, use both positive and negative values of the determinant for calculation. Yes, very interesting. Now, sometimes they can give you the area and they might tell you find out y1. But what is y1? Y1 is the coordinate. Now, can coordinate be negative? It can be negative. So in this case, the coordinates you can get negative, but area will always be positive. So if area is given, use both positive and negative values of the determinant for calculation. You'll get to understand this better with the help of example, don't worry. But to find only the area, it will always be positive. Make a note of this. Okay. So 3 points A x1, y1, B x2, y2 and C x3, y3 are collinear. Collinear means what? They lie on the same line. So 3 points A x1, y1, B x2, y2 and C x3, y3 are collinear if area of the triangle is 0. It's quite obvious, no? See, whenever you have 3 points, there are only 2 possibilities. One is those 3 points will form a triangle. Second is those 3 points are collinear. I hope this part is clear. So whenever you get the area of the triangle as 0, that means the 3 points are like this. There is no area. The area is 0. Area is not formed. Clear? So indirectly, we have half here, right? So if I take this half on that side, that half is anyways going to be eliminated because 0 divided by half is 0 only. That means this part is 0. That is, if 3 points are collinear, this determinant is 0. If 3 points are collinear, this is 0. That's it. Correct? Let us see an example. Find the area of triangle with vertices A 1, 2, B 4, 6 and C 5, 2. So basically what is given to us? 1, 2. Can I say this is x1, y1? 4, 6. That is x2, y2? 5, 2. This is nothing but your x3, y3. So x1, y1, x2, y2 and x3, y3 is given to us. Correct? Let us move on to the solution. We need to find out the area. Just put the values. Very simple. So we'll write down half of mod of determinant of. See here. x1, y1, 1, 2. x2, y2, 4, 6. x3, y3, 5, 2 and then 1, 1, 1. Now solve this carefully. So this becomes half of, correct, mod of course, and inside that there is determinant. So we have 1, 6 ones are minus 2 ones are 2. Then this will be minus 2, isn't it, in the middle? 4 ones are 4, 1 5s are 5. And then finally you have 1. And then 4 2s are 8, 6 5s are 30. Solve this further. You get half of 6 minus 2 is 4. 4 minus 5 is minus 1. This is minus 2 multiplied by minus 1. 8 minus 30 is minus 22. Solve this further. You get half of 4 ones are 4. Minus minus becomes plus 2 and then minus 22. That is 22 is negative, 4 and 2. They are positive, we'll add them. You get minus 16 here. But obviously, modulus of minus 16 is 16 and then half of 16 is 8. So 8 square units is the area of this particular triangle. I hope this part is clear to you and simple. Let's continue. Okay, interesting question. Check if points A, B, C are collinear. Again, what is given? x1, y1, x2, y2, x3, y3. So whenever we are supposed to check, no need to take that half. Just take the determinant x1, y1, 1, x2, y2, 1, this should be 0. If it is 0, they are collinear. Let us see. So here it is 1 to x1, y1, 3, 4, x2, y2, 5, 6. You can solve this further. You know how to solve this now. So I am not repeating this part. Solve it. Open the bracket. Right? Minus 2 plus 4 minus 2. Cancel. Answer is 0. Since the answer is 0, answer means what? The determinant is 0. Correct? This shows that The 3 points are collinear. Clear? Simple? Okay. Now comes a new topic. Now we are going to talk about what are minors and cofactors. So minor and cofactor. Again, we need to have a matrix to find out the minors and the cofactors. We need to see the definition also. So let us talk about minors first. The minor of an element. We take the minor of element. Element means what? Suppose if there is a 2 by 2 matrix, so there are 4 elements. So every element has some minor. So minor of an element of a determinant is the determinant of the matrix that is obtained by deleting the rows and columns in which the element lies. Okay, so this might sound confusing, don't worry, we'll see it slowly. The minor of the element Aij is given by Mij. That means if you have an element, say A, first row, second column, whatever that element is, the minor of this element is written as so the actual element is A12, the minor is written as M12. Clear? So for that, let us consider a 3 by 3 matrix. So here we have a 3 by 3 matrix. Now, understand what is the first element. Can I say the first element is 1? So ignore the first row and the first column, and the minor of the element A11, that is the element at the first row, first column, is obtained by deleting the first row and first column. So M11 is nothing but the determinant of the remaining terms. Let us see this once again. We have a matrix. We have the first element. So can I say this is first row, first column? Yes. Can I say this is like your A11? This is the element A11. But what we want to find? We want to find M11. And how do we find that? We find that by deleting the row and the column. So let us delete. So delete this also basically. What is remaining? The remaining are 4 terms. Put it in the form of determinant and that will give you the minor. So minor of 11 is the determinant of 5, 6, 8 and 9. 9 5s are 45, 6 8s are 48, subtract them. Minus 3. So M11 is minus 3. A11 is 1. A11 is 1. M11 is minus 3. I hope this part is clear to you. Simple. Let's continue. Now let us talk about cofactors. But before that, I would like to give one more example here. Now let us say they tell us to find out the minor of this. Suppose. So identify the row and column. Can I say it is second row, third column? Second row, third column. So can I say A23 is 6? Now how do we find out M23? So can I say M23 will be, delete the second row, delete the third column. What is remaining? 1, 2, 7, 8. Write it down. Solve this. 8 ones are, 7 twos are, subtract. You get minus 6. So A23 is 6 and M23 is minus 6. I hope this part is clear. Cofactors now. So the cofactor of an element in a determinant is the minor of the element. So to find out cofactor, you will find out the minor. Cofactor of an element in a determinant is the minor of the element. So minor you have to find out multiplied by minus 1 raised to I plus j, where I is the row and j is the column. Okay, let us see how do we find that out. And cofactor is given by Cij. See, the element is Aij, the minor is Mij, and the cofactor is Cij. So now we are going to see how to find out the cofactor. Let us continue. So here is an example. So this is the matrix and supposed to find out the cofactor of the first element, that is A11. So to find out A11, firstly we will find out M11, correct? So M11 is here. That is M11, isn't it? We'll ignore the first row, we'll ignore the first column. We'll take 5, 6, 8, 9. That is your M11. And what we are going to do is, we are going to multiply that M11 with minus 1 raised to I plus j. That is minus 1 raised to I plus j. What is I? I is the first row. What is j? J is the first column. That is why minus 1 raised to 1 plus 1 is minus 1 raised to 2, which is 1. And that is why you have 1 here. So here you get minus 3. So basically A11 is 1. M11, see, M11 is minus 3. And C11 is also minus 3 in this case. So does that mean that M11 and C11 will always be the same, or Mij and Cij will always be the same? Let us see how. If I tell you to find out, now suppose we have to find out the cofactor of, say, we have this element. So identify that. Can I say that is second row, third column? And A23 is 6. We'll find out M23 first. For that, we'll delete this row, we'll delete this column. What is remaining? 1, 2, 7, 8. That is equal to 8 1 the 8 minus 7 to the 14. So that is your M23. So what is your C23? C23 is minus 1 raised to 2 plus 3 and then M23. But M23 is already minus 6. And minus 1 raised to 2 plus 3 is minus 1 raised to 5. That is the odd power of minus 1. That is minus 1. Minus 1 multiplied by minus 6 is how much? And that is your final answer. I hope this is clear to you. So A23 is 6, M23 is minus 6 and C23 is 6. Clear? Okay. Now we will see how to find out the determinant using cofactors. So we are going to find out the determinant with the help of cofactors. The determinant of a 3 by 3 matrix can be calculated by expanding along any row or any column using minors and cofactors. Let us see how. So the determinant of A is given by A11 times C11, A12 times C12, A13 times C13. Let us see an example. So here you have a matrix A. The elements are 1, 2, 3, 4, 5, 6, 7, 8, 9. Now let me find out C11 first. How do we find out C11? C11 is minus 1 raised to 1 plus 1, M11. You know how to find out M11. When ignore this, take the remaining terms here, solve it, you get minus 3. We have anyway solved this in the previous slide as well. Okay. Now C12. What is C12? C12 will be minus 1 raised to 1 plus 2, correct? Multiplied by M12. This is 1, 2, first row, second column. We'll ignore this. We have 4, 7, 6, 9. We solve it. You get 6. Then we'll find out C13. What is C13? Minus 1 raised to 1 plus 3 into M13. That is further equal to minus 1 raised to 1 plus 3 is 4. So we'll have the positive 1 over here because minus 1 raised to even power of minus 1. That is 1. 4, 5, 7, 8. You solve it, you get minus 3. Now what is determinant of A? 1 multiplied by minus 3. So 1 is from here, minus 3 is from here. Then we have 2 multiplied by 6. 2 is from here, 6 is from here. And finally, we have 3 multiplied by minus 3, and that is 0. So, if you find out the actual determinant of this matrix, you will get 0. And if you remember, we have solved this example previously where we got the answer as 0 as well. I hope this part is clear to you. Okay, let's continue. Now find all cofactors of 1, minus 2, 4 and 3. Now this is a 2 by 2 matrix. So how do we find out the cofactor? The cofactor of this matrix is very easy because there are only 4 terms. So we will have C11, C12, C21, C22. How do we find that out? Have a look at this. So firstly, let us find out C11. To find out C11, if we use the formula, that is minus 1 raised to 1 plus 1 M11. So first row, first column you will delete, only 3 is remaining, no? So M11 is 3. So you get minus 1 raised to 1 plus 1 multiplied by 3. So minus 1 raised to 1 plus 1 is 2, that is 1. 1 multiplied by 3 is 3. That is why if you see, they have got the answer as 3 directly. Okay. Now if I talk about this one, the cofactor of minus 2, you will have minus 1 raised to 2 plus 1. So this will be negative, isn't it? Minus 4, because you will have minus 1 raised to 2 plus 1 or 1 plus 2, sorry, first row, second column, same thing in terms of solving. Minus 1 raised to 1 plus 2. So minus 1 raised to 3, that is negative, multiplied by 4. So we'll get minus 4. Now let us talk about 4. So for 4 again, we'll take this, but this is second row, first column. So minus 1 raised to 2 plus 1, that is minus 1 raised to 3, which is negative. So negative of negative 2 will become 2. See? And then finally for 3, that will be directly 1. That's it. So in this way, we can find out the cofactor of all the elements of a given matrix basically. Let's continue further. Now find all the cofactors of the element A23 of this particular matrix. Now see, it is very simple. We are just supposed to find out A23 of this particular matrix. Second row, third column. Second row, third column. See, this is R1, R2, R3, C1, C2 and C3. Second row, third column. So can I say this row, this column, that is 1. So A23 is 1. And we are supposed to find out the cofactor of that. Let us see how do we do that. So this is the matrix given. Now for A23, it will be minus 1 raised to 2 plus 3, isn't it? And we'll remove that row and column. So minus 1 raised to 2 plus 3, M23. But M23 is this, the remaining elements, that is 5, 3, 1, 2. And we know how to solve this. Minus 1 raised to 2 plus 3, this is 5. So odd power of minus 1 is going to give me minus 1 only. And this is what? This is nothing but your minor. 5 2s are 10, 3 1s are 3, 10 minus 3 is 7, but we have a negative sign outside. So the final answer is minus 7. Clear? I hope this part is clear and simple. Let's continue. Okay, now we are dealing with a new topic, which is called as the adjoint of a matrix. Let us try to understand what is the meaning of adjoint of a matrix. So, the adjoint of a square matrix, obviously the matrix has to be a square matrix first, is the transpose of its cofactor matrix. Now understand there are two things. First is cofactor matrix, second is taking the transpose. So suppose if A is a matrix of any order, say n, and it has the elements aij, then the adjoint of the matrix is given by the transpose of the cofactor matrix. So you need to find out the cofactor, you need to take the transpose. Now what is the meaning of transpose? Transpose means interchanging rows to columns. I'll give you a simple example. Now suppose we have a matrix 2, 3, 5, 6. What is the first row? The first row is 2, 3. That will become your first column. What is your second row? 5, 6. That will become your second column. This is transpose. Same applies to 3 by 3 matrix. Okay. This is the meaning of transpose, not the cofactor matrix. Cofactor matrix, I'll tell you. Find the cofactor of each element. Each and every element will find the cofactor. Will form the cofactor matrix. Will write all the elements in the matrix, the cofactor elements. And then we will take the transpose of the cofactor matrix to get the adjoint. Let us see how. So find the adjoint of the matrix, this one. Now there are 9 elements. So this is A11, A12, A13, A21, A22, A23, A31, A32, A33. Firstly, we need to find out from C11 to C33. We'll find out the cofactor of all the matrix. So let us see that. So firstly, let us focus on finding the cofactor of A11. How do we do that? Minus 1 raised to 1 plus 1, M11. Correct? M11 is 1460. You solve that, you get minus 24. So this is going to be a bit lengthy procedure. Correct? Now let us focus on finding C12 is what? First row, second column. Minus 1 raised to 1 plus 2, M12. For M12, you will take 0540. This becomes minus 1 only because here you have the odd power of minus 1. That gives you 20. Third, that is 3. C13. Minus 1 raised to 1 plus 3. Even power, so this becomes positive. M13, 0156. Take 0156. Solve this. You get minus 5. Only 3 are done. 6 more. Let's continue. For 0, we'll ignore the second row, first column. This is second row, first column. So 2 plus 1 is the power. And then what do you have? 2360. 2360 solve. For 1 again keep solving. Take your time to understand, analyze, observe. Put the values. Last 3. Correct? I hope this part is clear to you. So now we have from C11 to C33. Now we'll create a matrix of this. That is, we'll write down all the cofactors here. C11, C12, C13, C21, C22, C23, C31, C32, C33. Here is the matrix. So this matrix is called as cofactor matrix. This A is different and cofactor is different. Now to take the adjoint, what we are going to do is, this first row we'll write in first column, second row we'll write in second column, third row we will write in third column. So let us take the transpose of this. So we have the cofactor matrix, and to take the adjoint, what we will do is, first row will become first column. See, observe, this is the first row, first column, second row, second column, third row, Third column, that's it. And this is called as the adjoint matrix. This is your adjoint matrix. I hope this part is clear. And this is your cofactor matrix. And this is your original matrix. So in this way, you find out the adjoint matrix by taking the transpose of the cofactor matrix. I hope this part is clear. Now let us deal with a new topic, that is inverse of a matrix. So what exactly is the inverse of a matrix and how do we find that out? The inverse of a square matrix, say for example A, it is denoted as A inverse, and the inverse exists if and only if the determinant of A is not equal to 0. The determinant of A is 0, that is, if the determinant of a matrix is 0, it is also called as a singular matrix. Then we can say that we cannot find out the inverse. We can find out the inverse only when the determinant is not 0. And how do we give that? What is the formula? The inverse, that is A inverse, is given by 1 by determinant of A multiplied by adjoint of A. That means to find out the inverse also, you need to find out the adjoint matrix. And then you need to find out the determinant as well, which should be non-zero. And obviously it should be non-zero because 1 by 0 is not defined. So if determinant of A is 0, we won't get the inverse, no? Clear? Okay. Let us see this with the help of an example. And also there are some conditions for invertibility, that the matrix must be square matrix, of course, and the determinant of the matrix must not be 0. Clear and simple conditions. So find the inverse of the matrix. Now this is a 3 by 3 matrix and we are supposed to find out the inverse of the matrix. If you remember the formula, we need 1 by determinant of A multiplied by adjoint of A. So determinant by default we have to find out. So let us find out the determinant of A. Here it is. So we'll start with 2. Correct? So 2 multiplied by 3 multiplied by 0 minus 2 multiplied by 0. This middle one, negative, 1 zeros are and then 2 ones are. And then finally we have 1 and these two, product and then subtraction. Solve this further. So this is 2 as it is, 3 zeros are 0, 2 zeros are 0, so this will be 0 only. 1 zeros are 0, that will be negative 2. And finally we'll have negative 3. So the overall answer to this is negative 1. Is it 0? No. If it is not 0, that means inverse exists, right? Inverse exists. That means we can find out the inverse. Correct? Okay. But now we need to find out the adjoint of A. And you know how to find out the adjoint. You need to take the cofactors. You need to take the transpose. Then only you are going to get the adjoint. So let us begin. We calculate cofactors first. So we'll calculate the cofactor of this C11, that is minus 1 raised to 1 plus 1 M11, which is equal to what? You remove the row, remove the column, if you remember, to get the minor here, that is 3200. Solve it, you are getting 0 only. First one is done. Then C12, first row, second column, this one, right? You ignore this, minus 1 raised to 1 plus 2, and then 1120. So take 1120 here, 1120, or you can read it like 1210. Answer is 2. C13. You just have to observe now. You know the procedure. Correct? This will become positive 1 because even power, and then you get minus 3. So you have C11, C12, C13. That is your cofactor matrix C11, C12, C13. Now C21, C22, C23. Let us do that. So C21, C21. So you'll ignore this, minus 1 raised to 2 plus 1, 1100. Solve this. C22, correct? Solve it further. C23, that is for 2. I hope this is clear, so that you get to know how we are getting the values. Last 3 are pending. We need to focus on that as well. So C31, we are talking about this. correct? So this row will go, this column will go, you'll have 1, 1, 3, 2, solve it, you get -1. For 0, you get -3, and for last 0 there, this will go, this will go, this will go, and then you have 2, 1, 1, 3. So we have all the values now. We have C11, C12, C13, C21, C22, C23, C31, C32, C33. Correct? Okay. We first calculate the cofactors. That means we are going to find out the cofactor matrix. Put everything here. So that is your cofactor matrix. If you recall the previous slide, you have just put the values here. Now take the transpose. So transpose means what? Row will become column, right? So see, this row 0, 2, -3 comes in the first column. 0, -1, 1 comes in the second column. -1, -3, 5 comes in the third column. And in this way, you can find out the adjoint. Still our question is not done because we need to find out the inverse. And the inverse is given by, how do we calculate the inverse? 1 by determinant of A, adjoint of A. So determinant of A was -1. So this is -1. The overall result is -1. Now you multiply -1 inside and change the signs. That is your final answer. See, -1 becomes 1, 2 becomes -2, and so on. So this is your A inverse. I hope this part is clear. And what do you get by this inverse? What is the meaning of that? The meaning is that if you multiply both of them, you will get an identity matrix. This we have also studied in matrices. That if you multiply A and A inverse, you get identity. So suppose if you want to check whether your answer is right or wrong, what you do is you multiply both the matrices and you see whether you are getting if you get this, your answer is correct. Okay, let's continue. Now let us see some of the theorems on adjoint and inverse of a matrix. So if A be any given matrix, any given square matrix of course, of order n, then adjoint of A and A, if you take the product, that is A multiplied by adjoint A, or adjoint A multiplied by A, it will give you AI. What is I? I is the identity matrix. Simple. I is the identity matrix of order n. Second theorem or property. Anyways, you are not going to have a question directly on this. If A and B are non-singular matrices, that means non-singular means the determinant is not 0. If A and B are non-singular matrices of the same order, then AB and BA are also non-singular matrices of same order. That means if you multiply A and B or you multiply B and A, they are also going to be non-singular matrices of the same order. The order is not going to change. The determinant of the product of matrices is equal to the product of their respective determinants. That means what? If you find out the product of A and B, that is two matrices, you multiply them and then take the determinant, or you take the determinant of A first, then you take the determinant of B and multiply those two determinants, still the answer is going to be the same. So it doesn't matter whether you multiply the matrices first and then take the determinant, or you multiply the individual determinants. Fine. A square matrix A is invertible if and only if A is a non-singular matrix, and we know that. We can find out the inverse only when the matrix is a non-singular matrix, otherwise we cannot find out the inverse. Okay. A square matrix A is said to be singular if determinant of A is 0. When is the matrix called as a singular matrix? Whenever the determinant is 0, we call it a singular matrix. Now here is an example. We have a matrix 2, 3, 4, 6. So let us find out the determinant. 6 2s are 12, 4 3s are 12. Subtract them, you get 0. So since the determinant is 0, you can say that this is a singular matrix. I hope this part is clear. And if the matrix is singular matrix, we cannot find out the inverse. We cannot find out the inverse. A square matrix A is said to be non-singular if A is not equal to 0. We know this, right? A square matrix is said to be non-singular if the determinant of A, it should not be A, it should be like this, if the determinant of A is not equal to 0. Here is an example. 7 6 are 42, 4 3s are 12, 30 not equal to 0. So whenever it is not equal to 0, we can say that we can find out the inverse. We can find out the inverse. Clear? Okay. Now we'll see some applications of determinants and matrices for solving the system of linear equations. Now this is very important. Linear equations in grade 10 we have already studied. How do we solve linear equations? In that case, we used to have equations. We used to solve by elimination method. Sometimes we also used to use the substitution method or cross multiplication method. But those same linear equations can be converted into matrices and we can solve them using the help of the matrices and determinants. But how? We'll see that. So, the application of determinants and matrices for solving the system of linear equations, that is more than two or more than two linear equations, in 2 or 3 variables, and for checking consistency of the system of linear equations. Consistency means whether the two lines are parallel, they are coincident or intersecting. That is what we can check. So system of equations is said to be consistent if it has one or more solution. Basically, if the linear equations has one solution or more than one solution, that means either they are intersecting, the two lines you can say, or they are coincident, then only you are going to get more than one solution. So in that case you can say that they are consistent and they are parallel. If the lines are parallel, that means we can say that they are inconsistent. So when do we say they are inconsistent? If its solution does not exist. So this is a theoretical thing. You don't have to visualize anything. You don't have to actually draw the lines, linear equations and all. But with the help of matrices, we are going to see how we can solve these questions where we can find out the variables, values of the variables basically. Okay. So system of linear equations is said to be consistent if it has at least one solution. Same thing. The general form of linear equations. I hope you remember what is the general form of linear equations. It's given like this: Ax is equal to b, where A is the coefficient of the matrix, x is the vector of unknowns, and b is the constant vector. So in this way you can give the general form of system of linear equations. Okay, now let us talk about the conditions of consistency. A system is consistent if the determinant of the coefficient matrix A is non-zero. If the determinant of the coefficient matrix is non-zero, then only we can say that the system is consistent. And if the determinant is not 0, then it has a unique solution. So if you find out the determinant of a matrix and if you get that the determinant is not equal to 0, that means if it is a non-singular matrix, then you will say that it has a unique solution. And if the determinant is 0, but the system has at least one solution, the system is still consistent, but it has infinitely many solutions. Now whenever you get 0, that means you will have infinitely many solutions, right, to those equations. Now let us see an example that will give you a better clarity actually. So here consider the system of linear equations. We have two equations, x plus 2y is equal to 5 and we have 3x minus y is equal to 4. So these are the linear equations in two variables basically. In 10th grade you know how we used to solve these. We used to write it vertically, then make the coefficient of x and y same, and then we used to subtract or eliminate and get the values of x and y. So now let us see how do we solve this. So we have these two equations. You can convert the coefficients of x and y in terms of a matrix first. How? The coefficient of x is 1, the coefficient of y is 2. So 1 comma 2, that is 1 and 2 goes in the first row. Here we have 3, here we have minus 1. that goes in the second row. I hope this part is clear. So this becomes 1, 2 and 3 minus 1. Now we'll find out the determinant. So find out the determinant. 1 multiplied by minus 1 and then 2 multiplied by minus 3, 2 multiplied by 3. The final answer is minus 7. Is it equal to 0? No. The determinant is not equal to 0. So what can we say about this? We can say that the system is consistent, and whenever we get the determinant not equal to 0, it has a unique solution. So the solution is unique. That means if you solve this, these two lines are intersecting lines and you will have only one value of x and y. Okay. A system of linear equations can be solved using the inverse of the coefficient matrix if matrix is invertible. So if the matrix is invertible, the system of linear equations can be solved using the inverse of the coefficient matrix. Let us see how. So for a system of equations in the form Ax is equal to b, x will be what? X will be given by A inverse b. See, we have Ax equal to b, and if I want to find out x, which is the unknown, I can transpose A to the other side. So x is how? A goes on the other side. That means you find out the inverse. You already have b. Multiply both of them. You get the unknown. We will see that with the help of the example as well. So where A inverse is what? A inverse is the inverse of the coefficient matrix A. Now, let us solve the system of equations using the inverse of matrix. We are going to solve this with the help of inverse of matrix. Now, it's very simple. Firstly, we will write down this system in the form of Ax is equal to b. Now, what is A? A means the coefficients of x and y, that is the matrix. What is x? X is the unknown, which is x and y. And what is b? B is the elements on the right hand side. So let us see how to put this. Observe, 2x plus 3y is equal to 5. So 2 and 3 goes in the first row. 4 and 1 goes in the second row. So that is your matrix A. The elements on the right hand side, 5 and 6, they go here in the matrix B on the right hand side, and x and y are the variables, that is like your x, so that goes here. So I hope you have understood how to write this down first. So this is the way you write down. Now to find this x and y, you need to take this here. This is nothing but your A. When you take A on the other side, that becomes A inverse. So find out the inverse of this. That is our goal. Okay, let's continue. So find the inverse of the coefficient matrix A. Here we already have. Now this is matrix A. This is x and that is B. Let us find out the determinant of A, because to find out the inverse of matrix A, we need to find out the determinant first. So 2 1s are 2, 4 3s are 12. So 2 minus 12 is minus 10. That is not equal to 0. That means inverse exists. Now we'll find out the adjoint of A. So adjoint of A you can directly find out. This is A. I'll tell you a simple trick to find out adjoint. Just reverse this. That means take 1 here, 2 here, interchange. Keep the other two elements. That means for the leading diagonal you will interchange. For the other elements in the diagonal, you will just change the sign, minus 3, minus 4. Directly you will get the adjoint for 2 by 2 matrix. Simple way. Now after taking the adjoint, you know what is the formula to find out the inverse. Correct? Inverse is 1 by determinant of A, adjoint of A. Instead of determinant of A, what are you going to put? You are going to put minus 10. Adjoint of A you already have. Just solve this. So 1 by minus 10, 1, minus 4, minus 3. Minus 10 you divide everywhere. What do you get? You will get A inverse. Correct? Obviously, you can multiply it here or you can keep it like this only. And then to get x, you need A inverse into B. B you need there. So let us take B as well. Now you multiply these matrices. Keep 1 by minus 10 as it is, or else if you want to multiply here first, you do that. Now I hope you know how to multiply this. first row with this column. So 1 goes with 5, minus 3 goes with 6. Similarly, second row, here only one column is there, second row one column, minus 4 goes with 5, 2 goes with 6. Now solve this further. Inside the bracket you have 5 minus 18 minus 13 minus 20, and this is 12, that is minus 8. Now take minus 10 inside. So if you take minus 10 inside, this becomes minus 13 by minus 10, which is 13 by 10, and the second one becomes minus 8 by minus 10, which is 8 by 10, which is nothing but 4 by 5, and you have got the values of x and y. I hope this part is clear to you. This is how you can find out the values of x and y. Clear? Let's continue. Now using A times A inverse, solve the following system of equations. Okay. Now, there are three equations given to us. 2x minus 3y plus 5z. Obviously, you have here 3, 2, 4. Minus 4 you have here. 1, 1 minus 2 you have here. Okay. Let us solve this. So this is a 3 by 3 matrix. So definitely this is going to be a lengthy question for you. Firstly, this is your matrix A. Let us find out the determinant of matrix A, because we need to know whether the inverse exists or not. So you know how to find out the determinant. You will take 2, multiply these. Then you will take minus of minus 3. That is why here we have plus 3. Solve it. And then we have 5. Solve it further. The result of this is minus 1. Is minus 1 equal to 0? No. Minus 1 is not equal to 0. So clearly we can say that the inverse exists. Okay. We can solve this further now. So this is our matrix A. Now we need to find out the adjoint matrix, right? So these are all the elements of the adjoint matrix. You have done it directly now. You know how to find out the adjoint. Let us put it in the matrix now. So this is your adjoint matrix. Remember, to get the adjoint matrix, you need to find out the cofactor matrix first and then take the transpose. You do that, you will end up getting this. Clear? Now you know how to find out the inverse, right? So A inverse is adjoint of A 1 by determinant of A. Solve this now and you get the elements, because if you see, the adjoint of A is this and our determinant of A is what? Minus 1, no? So this is 1 by minus 1. If you multiply minus 1 inside, this will become plus, 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 minus, minus. Same thing we are doing there. That's it, you have got the inverse. And then this is your A inverse, that is your final answer. I hope this part is clear. Now we have x, y, z, and now we have b. So we know that to get x, we need A inverse b, isn't it? So remember, Ax is equal to b. So x is what? A inverse b. But this we already have. This we already have. And we have x, y, z. Why? Because there are 3 variables. We'll continue further. So multiply. How do we multiply? 0 goes with 11, 1 goes with minus 5, and 2 goes with minus 3 in the first row. Then minus 2 with 11, 9 with minus 5, minus 23 with minus 3 in the second row. Minus 1 with minus 5 and minus 13 with their corresponding elements. And finally you will get, this is 1, this is 2, this is 3. Just compare, x is 1, y is 2, z is 3. X is 1, y is 2, z is 3. And in this way you can find out the values of the variables. I hope you enjoyed the session here on determinants. So keep practicing and keep learning. I'll see you in the next class. Thank you.